All right, welcome back. This is Mr. Richards with Color Coded World. Today we are going to be going over our model of the momentum mass velocity triangle. Taking a look at it, right here we have our standard version in black and white, P equals mv. What does that mean? It means P equals m times v, and P is our momentum. Momentum is measured in kilograms times meters per second, followed by our mass. Our mass is measured in kilograms, and our V is velocity measured in meters per second moving forward, with an example sample on how to utilize and manipulate the tool. So we do have our triangle here. We also have right here on how to use the triangle, again, just like the last page. So our first set of three we're solving for P. Now is P momentum, or is P the M, the mass that's measured in 5 kilograms? Well, let's take a look at our triangle. Oh, P must be momentum, and it's measured in kilograms times meters per second. So what we can do is we take what we are given, our 5 kilograms. We'll put a 5 here because it's in blue. It's also our mass and measured in kilograms. Then we will take our velocity, which is 6 meters per second. We will take our 6, we will put it here. We know it's green, it goes right by the green V, and it's also measured in meters per second. We would do 5 times 6, and we would put our 30 here, and our momentum is 30 kilograms times meters per second. For the mass, we would do the exact same thing. We would put our 56 up top by momentum because it's 56, it's in red, it's measured in kilograms times meters per second. Then we would take our 8 right here and put it in but next to our green V for meters per second. We would do the 56 divided by 8, giving us a mass of 7 kilograms. And then for velocity, we would do the same thing following the same format. Right here, we would put in our 36 up top. We would put our 4 by our blue mass. We would do 36 divided by 4, and we would get a velocity of 9 meters per second. Then for any parent, guardian, teacher to use with their students, learner, or learners, we can just plug in anything on a whiteboard or a chalkboard, or just tell our students, hey, we are going to solve for P this problem. We're going to solve for M this problem, or V for the following. Print as many as you would like and use and reuse with all of your learners, student, or students. Moving forward, and then we have some word problems. We have 11 of them. I won't cover them all. I'll cover over one on the first page and one on the last page, just to give you guys the example of how this flows and follows, and that our learner, student, or students can plug in any numbers and chug along. But we will start with the basic on the first. What is the momentum of Jake's remote control car if the mass of the car is 3 kilograms and it's traveling north at a velocity of 10 meters per second? So first we're going to plug in what's given to us. Okay, we have mass, 3 kilograms. It's in blue. We have a blue M. We would put our 3 kg. Oh my goodness, it's giving us velocity in green of 10 meters per second. We would put in our 10 meters per second here. And then we would just look, oh, how do we solve for momentum again? We would do M times V, so 3 times 10, giving us 30 kilograms times meters per second. Then you also have some more samples to use, but check it out on the last page. And this is the prime example of how once we know a formula, how to manipulate a formula, it's just a matter of plug and chug. Okay, so right here even, we would do our 1110 for our momentum. We would put in our 55. For velocity, we would do 1110 divided by 55 to solve for the mass. And that pretty much completes it. Then you would get a blank one that you can use for any triangles, formulas that you can use for your students, learner, or learners. Have a beautiful, blessed day, all. Thank you so much for viewing.